This is Mr. Hassan's Maths channel. I'm now answering question number 4 from the October-November 2019 Mechanics paper 4 variant 3 from Cambridge 9709. And here we have a question all about kinematics and constant acceleration. It says a car travels along a straight road with constant acceleration. So there's a keyword, constant acceleration. It passes through the points P, Q, R, and S. The times taken for the car to travel from P to Q, Q to R, R to S are each equal to 10 seconds. The distance QR is 1.5 the distance PQ. At point Q, the speed of the car is 20 meters per second. Show that the acceleration of the car is 0.8 meters per second squared. Now, as with nearly all mechanics problems, it is almost essential for you to be able to picture and visualize what's happening. And that can be done easily by drawing a clear diagram. So I'm going to draw the straight horizontal road. Okay. I'm going to mark on it some of the points that we have. So the car travels from P. So what's happened to the pen? 1 second. This is the point P. Okay. And let's say then it goes to Q. Okay, and then from Q to R and then R to S. But we know that P to Q is, or Q to R is 1.5 the distance P to Q. So I'm just going to kind of like illustrate that on the diagram. That's P to Q. Q to R is twice the distance from P to Q. So 1.5 times the distance. I'm just going to make it a bit bigger. I don't have to make it that much bigger. All right. And then we have S and R. We don't really know much about there. I'll just put them, anywhere. No problem. That's P, Q, R, and S. That's it. P, Q, R, and S. Okay. So I'll just get rid of that now. Okay. So it goes from P to Q, Q to R, and R to S. Okay. Now, what do we know about the situation here? Well, we know that the time between each of these is 10 seconds. So if this is 0, this will be after 10 seconds. This will be 20 seconds after it passes P, and this will be 30 seconds after it passes P. Okay. We also know that the distance between P to Q and Q to R is 1.5 times that distance. Smaller. So you got P to Q and Q to R. Well, let's say we say P to Q is a distance X, then Q to R is the distance 1.5x. We also know that when it's passing Q, we know its speed is 20 meters per second. When it's passing Q, its speed is 20 meters per second. And we know throughout the whole journey, the acceleration is constant. And that's what we have to find, that constant acceleration. We have to show that 0.8. I think that's all the information now marked on this diagram. So this is going to help us to figure out what points we can use. Like for sure, I'm going to want to use Q because I have about Q the most amount of information as compared to the others, right? And we want to find the acceleration. Now we have some way to relate P and R together, okay? Because we know their relative distances in terms, I can find the distance from P to Q and Q to R. I can kind of express them with the same, variable, right? So I think I've got to use P, Q, and R in our situation. So what I'm going to do first is I'm going to consider from P to Q, right? So when you use suvat, you have to be very, very clear about what you're doing. Okay, it's very, very important that you are like very clear about what you're doing. So when I say P to Q, okay, then I've got to put my values in very carefully. So I'm going to put suvat. So I always write my suvat values. So S is the displacement between those two, which is X. Between P and Q, we called it X. U is the speed of P, the speed at when it's at P. So I'll just put that as VP. V is the speed when it's at Q, which we know is 20. Okay. Acceleration is what we're trying to find. And between P and Q, the time it takes is 10 seconds. Okay. And I'm going to do the same thing between Q and R. Q to R. But this time our values will not all be the same because we're starting at Q and finishing at R. So in this case, the displacement here is 1.5x. And the initial speed is 20, because that's where it's starting. And the final speed, we don't know what that is. That's the velocity when it reaches r. The speed when it reaches r. Acceleration is what we're trying to find. And the time here is, again, 10 seconds, because it's between this time and that time, between 10 equals 20 and 10 equals 10. Sorry, t equals 10 and t equals 20. The difference between them is 10 seconds. It takes 10 seconds for it to get from Q to R. And that's what we're considering here. So if we look at the values that we have here, we have S, we have to deal with S. We have to deal with V, we have to deal with A, we have to deal with T. But here we have to deal with S, U, A, and T. So like, there's one equation for this, which is not in the formula sheet, which I highly recommend you to learn, which will make this question really easy. And that is, we all know in the formula sheet, you have S equals UT plus a half AT squared. And that's what we're going to use here, S, U, A, and T. But here there's a formula that we can use, which will make life easy instead of you going through a longer way of doing it. S equals VT plus minus a half AT squared. So S equals VT minus a half AT squared. Okay, so that's basically the formula that is very useful. It's not in the formula sheet, but it's going to make this question really easy. So I'm going to apply this formula to P to Q. So my S is X, my V is 20, my T is 10, minus a half times the acceleration is what I'm trying to find, and that's going to be 10 squared. So I've got X equals 200 minus a half times 100, which is 50A. So I have now an equation which has X and A. And if I use S equals UT plus a half AT squared for this one, because I know what U is, I've got 1.5x equals U, which is 20, T, which is 10 again, plus a half times A times 10 squared. So I'm left with 1.5x equals, that's going to be 200. That's going to be plus half times 100, which is 50A. So now I have these two equations, which I can solve them simultaneously. All right, so for example, I can take equation 1 and substitute it into equation 2. So I can replace the x here with 200 minus 50a. So I have 1.5x times 200 minus 50a is equal to 200 plus 50a. Okay, so now let's solve this. That's going to be 1.5 times 2, or 2 times that's 300. 300x, 1.5 times 50, that's 50 plus 25, that's minus 75a, is equal to 200 plus 50a. What have I done here? Sorry, silly me. The x is equal to this. There shouldn't be an x here. Ignore that. Should say times. Okay, so 1.5. Instead of x, I write 200 minus 50a. The x shouldn't be there. Okay, so now we're going to have 300 minus 200 on this side. I'm going to have 50a plus 75a. So I'm going to have here 100 equals, and that's going to be 125a. So that's going to be basically 4 over 5, isn't it? 100 over 125 equals a. That's going to be 4/5. Just to confirm that. So we're going to have 100 divided by 125, which is 4/5, which is 0.8. So a is equal to 4 over 5, which is 0.8 meters per second squared. So there we've shown what we had to show. Okay, so these type of questions, you have to just be really clear about where you're starting and where you're finishing, and the values you use for the starting and the end point. And then this formula is a very important formula. It's not in your formula sheet. Okay, you have all the other formulas, but this is not there. And I normally teach this formula because it becomes really useful in a situation like this. So I would really highly recommend that you know this formula. It's basically, basically what they are. They represent a rectangle and a triangle. Okay, you'll understand what I mean, hopefully. So the UT represents like a rectangle. Okay. And this is like a triangle on top of it. We'll just switch it around afterwards. All right. Just make it a bit thinner. Okay. So if I just flip this to make it better. Okay. So basically, this is basically UT is basically this, okay, in a speed times graph, and this is your half AT squared. That's the area of this, okay, this part here. And if you consider the whole rectangle, the area of the whole thing is V times T, because here this is U and this is V, right? So this is like a speed time graph. Okay, and this part is like the rectangular part. It's like, so altogether it's like a trapezium. So this is like the rectangular part. So you're going to have UT plus a half AT squared for the total area under the shape. But if you consider this rectangle, the whole thing, take away this, because these two are the same, take away this area, you'll be left with the same thing. So it's also VT minus a half AT squared. You can think of taking away this area from the whole thing, you end up with VT minus a half AT squared. It's the same as UT plus a half AT squared. They lead to the same area under the graph. So there's two different ways of thinking about that. That second formula is not given in the formula sheet, but the first one is. Okay, so this one is given, UT plus a half AT squared. This one isn't. So you should know this. It really helps you with such questions. It makes it very easy. All right, for now, for number 2 or part 2, I think I'm going to take this with me. Okay, because we probably need this diagram, I'm assuming. So part 2. Does it want to move with me? Come on. Let's move. Let's go. No. Give me a second. I'll sort that out. Okay. When I put it on pause, it moved straight away. Anyway, no problem. So now it says find the distance between Q and S. So we have to find this distance between Q and S. Okay, this is the distance we have to find. Okay, this is the distance to QS. You have to find that distance. And then find the average speed of the car. So please, in this type of question, remember there's 2 parts, okay, to the question. So it's very important that you don't just skim read it and forget that there's actually 2 parts. Many people will just find the distance QS and they'll forget about the average speed. So keep that in your mind from the beginning. So now, how do I find the distance QS? Well, we now know the acceleration of this is 0.8 meters per second squared. So let's look at Q to S. Let's look at what we know from Q to S. Okay, what do we know from Q to S? Let's make a bit of space here. Well, we know from Q to S that S is what we're trying to find. Let me call it Y. Okay, U is the speed at Q, which is 20 meters per second. V is the speed at S, which we don't know. A, we now know is 0.8. And the time it takes to go from Q to S, that's when time was 10 to 30, is going to be 20 seconds. Be very careful. Don't put T equals 30. That's 30 seconds after the start. We're now starting from Q. We're going from Q to S. So it's from 10 to 30, which is 20 seconds. That's why you have to be careful about things like this when you're dealing with suvat. You have to be very, very clear and precise about what you're doing. This is where we're starting. That's where we're finishing. So be very careful about that. Okay. So now, and if there's like direction problems, you know, there's no change in direction here, there's no problem. If there's going to be some change in direction, then you have to be very careful about what side you take as positive. And if there's a change in direction, that will affect everything. So you have to be careful about that. In this case, they're going in a straight line in one direction, so there's no issue there. Okay, so now we have to find S. We know U, we know A, we know T, S, U, A, T. Again, we can use S equals UT plus a half AT squared. So S is what we're trying to find. We call it Y equals U, which is 20, times T, which is 20, plus a half times A, which is 0.8, times T, which is 20 squared. So 20 squared. That's going to give me 400 plus 0.4 times 400. So it's going to be 400 plus, that's going to be 160, right? 160. Okay, because you move back one space. So that's going to be 560 meters. So we can say the distance between Q to S, QS is 560 meters. And don't forget the other part of the question, find the average speed. You don't want to lose any marks for that. So the average speed of an object when it moves from one place to another between Q to S, we want, is going to be the total distance it traveled over the total time it took. So from Q to S, it traveled 560 meters in 20 seconds. So that's going to be 56 divided by 2, that's 28 meters per second. Okay, 2 times 40 plus 60, yeah, 28 meters per second. So there we have the answer to this question. Okay, so it's a typical type of suvat, kinematics type of problem. And you have to just keep your mind very logical and clear, make a nice clear diagram so everything's in front of you. And you know, how did I know how to proceed? I looked at the place that we have the most information about. So I knew that we have to use this. And because we have some, expression for the distance between P and Q and R. So I thought, let's take P to Q and Q to R and see what we can find. How can we link them together? Well, we can link them together with the X and these two formulae, and we can then solve, right? So it's very important to think logically in these questions. I hope that was clear. Other questions from this particular paper you can find in the playlist that will be posted on the top here. If I'm asked questions from this, I will answer them. At the moment, I think this is the first one. But if I'm asked other questions, I will answer them. So you can check there if I have. If I haven't, you can ask me if you want. Send a message and I will try my best to get the answer done as soon as possible. Over here, you'll find a playlist dealing all about with kinematics and suvat. Okay, constant acceleration type of questions. You can subscribe to my channel by clicking on this link, and the video up here will show you how to use my channel to find those things that you might be looking for, whether it's IGCSE, whether it's A-level, whether it's Cambridge, whether it's Edexcel. I have some different material that you can browse over there. Thank you for watching and see you soon.